vibrant semiconductor ecosystem which focuses on infrastructure, research and development, encouraging the adoption of sustainable practices and green technologies in semiconductor manufacturing and global partnership to exchange the best practices. As the chairman of Gujarat Pollution Control Board, I am honored to welcome such a distinguished gathering of experts, industry leaders and stakeholders committed to the sustainable growth of this vital sector. The semiconductor industry stands at the forefront of technological innovation for shaping our modern world. However, it also brings significant environmental and safety challenges. The chemical and gases used in semiconductor manufacturing are indispensable. Yet, their potential impacts on the environment and human health cannot be overlooked. Today's session is dedicated to exploring these critical issues. We will delve into the complexities of managing hazardous materials, the latest advancement in the waste management, and the development of greener and safer alternatives. At the Gujarat Pollution Control Board, we are committed to fostering the regulatory environment that supports both innovation and sustainability. We believe that by working together, we can develop strategies that not only enhance the efficiency of semiconductor manufacturing, but also safeguard our environment. I encourage all participants to engage actively in today's discussions. Share your insights and collaborate on solutions that will drive our industries towards a safer and more sustainable future. Thank you, and I wish you all a productive and enlightening seminar. Thank you all.
Thank you so much, sir, for your warm wishes. Thank you very much. Now, to set the tone of the event, we have two brief presentations which will be followed by a panel discussion. And without much ado, I humbly invite the very first speaker of this session, Shri D.M. Thakurji, Member Secretary, Gujarat Pollution Control Board, to present on environmental permission regime and common environmental infrastructure in Gujarat.
Good afternoon, you all, distinguished guests, ladies and gentlemen. Today, main focus is a panel discussion and a presentation by Dr. of NERI, National Environment Engineering Research Institute. So I won't be much between you and this August panel. Only the thing is, in the morning you heard that Gujarat is going to be a hub for the semiconductor. And with semiconductor big companies, there would be a generation of an ecosystem. And vendor parks are coming with automobile industry. Similarly, here ancillary industry would come along with the main semiconductor industries. So we are required also to be equipped with say common environment infrastructures and other things. And Gujarat Pollution Control Board is making efforts for that. Only 4 to 5 slides I would like to appraise you how we are trying for the future ready organization. So this is a slide that depicts the industrialization of Gujarat. Gujarat is a growth engine of our country. And today you see, I mean, we are having a lot more contribution in the country's GDP. We are 6% of the populations and contributing more than 6% into GDP of the country. We are highest in soda ash, diamond processing, salt productions, petrochemicals, dyes intermediate, pharmaceuticals, pesticides, everything. And I hope after 2-3 years, then somebody else would be making presentation. Perhaps you will see semiconductor 95% plus as charting the this chart. When we talk about such high industrializations, there would be naturally a problem of the pollution, and we need to, I mean, resolve those problems to be on a path of a sustainable development. So what are the efforts that required to be on a path of a sustainable development along with a growth. This is a map of Gujarat, and you see these all red dots, which are, say, industrial clusters of the state. And from Vapi to Mehsana, we call it a golden corridor, where we have major chemical industrial clusters: Vapi, Sarigam, Ankleshwar, Nandesari, and Vatwa, and Udo, etc. You are seeing one green dot also, Dholera, that's going to be a semiconductor hub of the state. It will lead the country in the area of semiconductor. So this is perhaps a map which is showing that how industrialized state the Gujarat is. And this is the numbers of industries. We are having red category industries, orange category industry, green category industry. Simultaneously, we have all three sets of the industry: large, medium, and small. Chart depicts that we have a very strong presence of the small scale industry. And when we talk about small scale industries, their problems are different from, say, large scale industry, and we need to cater them differently. So how we are catering these problems of small scale industries? Small scale industries have the limitations of the fund, they have limitations of the other resources, they have limitations of the knowledge also. How to cope up, keeping industrial growth in pace, simultaneously meeting with the requirement of a pollution control and to be on a sustainable path. So Gujarat found that if you need to go, then common environment infrastructure is a key. If you will strengthen your common environment infrastructure, that can give you an answer of the pollution preventions by the small scale industry in particular. So we have a very strong presence of the common effluent treatment plants in the states. We have treatment, storage, disposal facility for the hazardous waste generating in the state. We have a common biomedical waste treatment facility. We have a community boilers. This is a novel concept. For each small scale industry, you cannot afford to have a small scale boiler. You need to provide them a common solution for the steam generation also, so that you can generate a steam with a high capacity boiler with a higher Rankine efficiency, reduction in the pollution at source. So this is a concept. Perhaps Gujarat is a pioneer, where we have, instead of multiple small boilers, we have a large size community boiler which caters the steam to the small scale industry. Started a pilot at Surat, now we are having its strong presence as Ankleshwar, Nandesari, and Vapi. So this is a very good and successful experiment of a Gujarat. Now it is being proliferated in the other states too. Similarly, semiconductor industries will generate e-waste also. We have a strong presence of the e-waste recyclers into the state. Simultaneously, we have common decontamination facilities too. What proactive measures, how we differentiate from, say, other states? I mean, several proactive measures have been initiated in the past and now further strengthened and continued in the states. Environment clinic is one of the steps where we make a approach of a facilitation, a approach of a doctor instead of a police, and we started this concept where we sit with the industry, try to, get their problems and try to offer them solutions through research and development or collaborations with academia and research institutes or through a common environment infrastructure problem. Simultaneously, Gujarat is a unique state. We started environment audit schemes where individual industry is audited by a third-party agency, recognized by the board, and evaluate themselves. This is a very unique concept, and now we are trying to strengthen this concept. ETS is also another another feather into a cap of a pollution control board. We are pioneers to start ETS PM in the states at a pilot. Now it is being, say, upscaled to many other clusters, started from the Surat, now it is being replicated into other industrial clusters of the Gujarat. reuse of the treated sewage, promotion of the circular economy. Surat is a success story at a national level where 70 to 80 MLD of the treated sewage is utilized by the textile industry. Others are also the tools which are helping industry, open house, help desk. Capacity building of the all stakeholders has also been our motive, where we try to give trainings to even ETP, and we are having R&D schemes. We are promoting PhD students also, and we are also giving internships to the environmental sciences students. So capacity building is also one of the important sectors, and all-round capacity building of all the stakeholders. It's a key, and we are trying for that also. Even we are conducting classes and say training sessions for the environmental auditors of the states so as to build all-round capacity. Similarly, promotion of the co-processing. Gujarat is also one of the pioneer states for the promotion of the co-processing, where waste is utilized either as a fuel or a resource in a cement industry. And we have very good statistics of waste being utilized as a resource in a cement industry. Similarly, those industries which are following the rules, those who are having ISO 14000 or a responsible care kind of certifications, we give them a consent of 1 more year too. So these are the tools for management of the environment also. This is our last perhaps good efforts that board has made, that it is an attempt to give governance in the hand of industry. We have introduced this vehicle location tracking system. We are the first state to have hazardous waste trucks monitoring system through GIS module. So this is an online system where industry, a sender industry of its hazardous waste, either for recycling or for a disposal, can monitor its vehicle online on his screen. Idea is to give a governance in your hand, how you should monitor yourself. We need not to monitor you. I mean, if you are compliant, if you are believing in self-regulations, we don't want to intervene in your businesses and processes. So this is an attempt for that, for the self-governance, voluntary governance. This is the important slides for the everyone. I mean, what is the environmental permission regime for the industries? We understand the introductions of the semiconductor industry will come with so many small and micro scale ancillary industries. I mean, there would be a supply chain industry and all those industries which are related with the chemicals, which are related with other processes and following into regime of a consent need to take basically 2 kinds of the permissions. First is environment clearance. If you are there into a schedule of EIA notification 2006, there is a list of activities as well as the products with a threshold. If you are coming into that, then you are required to take a prior environment clearance. And it is very important because it is a prior environment clearance. So starting any activity, before starting any activity, you need to take this permission. So this is a chart, and environment clearance is little time consuming too, because it has to follow screening, scoping, public consultation and appraisal, 4 steps, and which are major steps. In first steps, you are given terms of reference, what we call the screening and scoping, and in another steps, you need to carry out a public hearing by, say, regional officer of a Gujarat Pollution Control Board of that particular district in consultations with district administration, and then the appraisal. So these are the, time slots which are required for, say, granting you terms of reference or public consultations or the appraisals. So this is very important, that if you are falling into schedule of a year notifications, you are required to take environment clearance. But the industries which are related with, say, secondary metallurgical, there has been, say, revisions into norms and yardsticks, and now they are quite relatively relaxed, so that small-scale industry for the secondary metallurgical activity now is being, say, exempted from environment clearance. Simultaneously, along with environment clearance, you need to take consent to establishment and consent to operate of the board. Consent to establishment is a permission that you are required to take prior establishment, and consent to operate is required when you start your trial productions. So it takes about 45 days normally. So this is a permit regime for industries associated with semiconductor. So that's all. I mean, I won't be long between you and the expert panelists. I welcome you all on behalf of Gujarat Pollution Control Board, and I wish that this consultative process for, say, semiconductor environmental aspects would be very fruitful and useful to you. Thank you very much.
Thank you so much, sir, for that very informative presentation. Thank you very much. I now take the opportunity to invite Dr. Girish R. Pofali, Chief Scientist and Chair, Institutional R&D Infrastructure, Planning and Management in CSIR, National Environmental Engineering Research Institute. Dr. Girish holds a PhD in Environmental Engineering from Nagpur University and has 27 years project management, engineering design, and research experience within water and wastewater treatment system. And sir is going to present on water and wastewater treatment for semiconductor industry. Let's welcome sir with a big and warm round of applause. Thank you so much.
Thank you for the introduction. First of all, I would like to thank the organizers for giving me this opportunity to speak about the water wastewater management pertaining to the semiconductor industry. To set the tone, I would like to just give a thought that this industry which is coming in India is going to have a huge impact on economy, as well as it is going to have the environmental aspects. So I'm going to cover in brief, because I was told that there is a shortage of time, so I will be quick, but I'll be speaking three aspects of my presentation, which will cover what exactly is the issue related to water and wastewater management for semiconductor industry, and how is that, what are the challenges that would come when this industry come in the coming years, and what will be the way forward for this particular industry's the challenges. So as of now, we have been listening since morning about the other aspects of production, supply chain line. But this industry, when it comes, I would like to mention here that this is actually a water-intensive industry, one of the leading consumer of water. And with increase in demand for semiconductor production, the wastewater management would also become an emerging issue. So semiconductor industry has some processes. I won't go in detail, but for the benefit of our young friends, it has multiple, manufacturing process. Each of the manufacturing process involves use of various types of chemicals and reagents. So they actually generate different types of waste. Use of variety of chemical at various stages of manufacturing lead to complex composition of wastewater. I have actually worked in various industrial sectors across the country and various other foreign countries. But this particular industry is very new to us, and we do not have any first-hand experience. So the wastewater that is characterized according to the literature is either low or it has no biodegradability, and it contains heavy metals and certain degree of solvents. So there is one case study that I was referring about the Samsung Electronics, in which it was reported that the industry which was using in 2016 around 92 million meter cube of water, now in 2019 it used 166 million meter cube of water. I'm sorry you won't be able to see this figure, but I'll just let you know. And the wastewater generation that has increased also more than double. It was around 72 million meter cube to 131 million meter cube. So this actually set the tone that why do we need to look after the water and wastewater management for this particular industry. Now look at the type of pollutants. I was just referring to the processes. These are the processes. You can see the type of pollutant released from each of the process. It contains starting from antimony, hydrochloric acid, phosphorus, and all those in oxidation process. You can see these parameters which you are seeing, which are actually very difficult for management because they are either low biodegradable or they do not have any, provision of, they are recalcitrant organics. So this actually requires careful attention. So whenever we have this industry coming up, we need to see that each of these process and the chemical that are being used, it is going to give us this kind of challenge. And very recently, the one study was published in which it was said that the type of guideline or the standard we require if we have to dispose of this particular wastewater, it should meet these norms. Maximum 1 day can be like this, but for a 30-day consecutive discharge, you need to have pH 6 to 9, suspended solids up to 23, total toxic organics. This is something new for us, TTO. Under this TTO, there are many organics which are listed. I have not actually mentioned here for the shortage of time, but under this, they should be nil actually in our wastewater. This is according to the standard issued by EPA. Then you can see set of heavy metals starting from arsenic, cadmium, chromium, lead, zinc, and antimony. So these standards are applicable for already manufacturing industry in US. So as we know that Taiwan is a big producer of semiconductor chips and all other products. They have these norms. I have actually listed some of the major parameters. So when we take up our industry in India, we also have to look after these parameters, starting from heavy metals as well as parameters like cyanide, oil and grease, and also though we presently focus mostly on COD, suspended solids, and TTO. This is something new that I just informed. So the challenge is going to be is a multi-fold challenge when we take up the environmental, water-related issues in India. These are the discharge limits which are set by the EPA 2017 for Taiwan. Now, considering the water environment for this particular industry, we have certain challenges. What are those challenges that we need to understand beforehand? A complex nature of effluent generation owing to the fact that each manufacturing process generates different types of pollutant. And most importantly, absence of any first-hand information or secondary data with respect to Indian conditions would also pose major challenge in designing new wastewater management facilities. In addition to the constituents wastewater which are actually contributed by the process, the raw water quality also affect the effluent quality. That means we need to also see what is the raw water quality that we are getting for manufacturing the semiconductor industry. So, and then another thing, this absence of prescribed norms for water consumption, wastewater generation, and the outlet discharge norms for the semiconductor industry. This will also have some implication in designing new setups. So we have another, and one more challenge is that the selection of techno-economical and environmental sustainable treatment solution. Having said that, we have so many technologies available in terms of advanced oxidation processes, tertiary treatment systems, or membrane processes. So we need to actually select a techno-economically environment sustainable for our conditions. It would also be one of the key challenge. So having said that, we need to actually adopt a holistic approach. What that holistic approach would be, like development of effluent discharge norms for the semiconductor is the prime important thing. Then it is imperative that we have a segregation of effluent streams based on degree of similarity. There are certain streams which may not be biodegradable, or which are less biodegradable, or which have some recalcitrant organics. So we can take up those streams and treat either requiring advanced oxidation processes. Then separate treatment for biodegradable and recalcitrant components to optimize performance of advanced oxidation processes to minimize the capex and opex. And adopting multi-intervention approach, including tertiary and polishing treatment for recycle and reuse of treated effluent. Because we cannot allow the after treatment, after spending sufficient amount of money to just to dispose it off. So that the recycle and reuse of the treated effluent should also be targeted. And then, since we do not have any first-hand experience, so our skill development or capacity building of ETP operators is actually needed. So the criteria that we should adopt should essentially consider the three factors. The one is economic and technical and administrative criteria. In the economy criteria, we need to consider all these factors. They are like the capital cost, O&M cost, and land area required. And in technical terms, we have to comply with all the norms which would be set by the regulatory authorities, including heavy metal removal, TSS, BOD, all those parameters, sludge generation and handling, design versus operating flow. Many a times it is observed that the capacity which we design, it is all either under design or have a higher flow rate. And then, of course, we need to also consider the tedious part, which we are going to use as raw water. And the treatment system that we are adopting should have high ease of operation and sustainability. And of course, designated end of treated effluent should also be considered. So this criteria would probably help in selecting the best suitable treatment system to meet our requirement. Then way forward, that how that we move forward, that we are now considering it as investment rather than expenditure. But then there are certain challenges, like the social challenges, the administrative, financial, and technical. All these challenges actually give us an opportunity of pollution prevention, recycle and reuse. And ultimately, this meets the goal of sustainable development and environment conservation. So I think this is achievable, doable with when we consider this as a semiconductor wastewater management cycle. The concept of recycle and reuse and the circular economy would also help us in achieving the goal of sustainable development and conserving the environment. These are some of the references which I have used for preparing this presentation. Thank you very much for your kind attention. I have brought up the issue in limited time for the shortage. Thank you very much. If you have any questions, I would be happy to answer this. Thank you very much.
So we are taking all the questions in the last, after the panel discussion.
Yeah, thank you very much.
So thank you so much, sir. Thank you very much. That was a very informative presentation. And now we are moving towards our next segment, that is the panel discussion. It is my privilege to introduce the moderator of the panel discussion, Dr. Anurag Kandia, who serves as an associate professor at Pandit Deen Dayal Energy University. He holds a PhD in urban microclimate from IIT Delhi and has over 24 years of teaching and research experience. Sir, I would request you to join me on stage. Let's give a warm welcome to the moderator of our session, Dr. Anurag Kandia. So I think what I have been given here is a different surname. So this is Kantha, right? But okay, so यहाँ पे गलत लिखा हुआ है और मैं सही बोल रही थी. Thank God. सुन के अच्छा लगा मुझे. All right. So now moving towards our panelists, it's my again privilege to introduce our first panelist, Sri Anil Kumar sir. He is a scientist at Central Pollution Control Board. Sir is the Director and Divisional Head, Waste Management Division 3rd at CBCP, New Delhi. He has more than 30 years of work experience in environmental sector. Shri Anand Kumarji. Our second panelist is Shri Apurva Amin, AVP Facilities and Projects, CG Semi. He is a seasoned professional with 24 years of experience in projects and facilities management and is known for successfully completing large-scale greenfield projects. Our third panelist, Dr. Aman Desai, who holds a PhD in organic chemistry from Michigan State University and is currently director and co-founder of Ether Industries Limited, Surat, Gujarat. He has been awarded the UAA Young Achiever Award in 2018 from Institute of Chemical Technology, Mumbai, and was also awarded the Business World BW Disrupt 40 Under 40 Business Leaders Award in 2022. Our fourth panelist is Dr. Kinjal J. Shah, who works as an associate professor and distinguished foreign expert at the College of Urban Construction, Nanjing Tech University, China, and holds PhD in Applied Science degree from National Taiwan University of Science and Technology. Our fifth panelist is Shri Vinod Balakumar, who is serving as a counselor at CII Green Business Center in Hyderabad. Shri Vinod has more than 14 years of experience in the domains of energy efficiency and climate change. We welcome you, sir. And our final panelist is Shri N.K. Jain, who is the Vice President, Head Environment at Jubilant Ingravia Limited, focusing on sustainable practices in the chemical sector. He has 30 years of industry experience and has worked in industries located across 13 different states of India. Now, all our panelists are on the dais. Sir, I would request you to take this panel session forward. Thank you.
Hello. Yeah, thank you very much for the lovely introductions of all the panelists. And indeed, it's a great pleasure and honor for me to moderate this very important session on environmental safety focusing the semiconductors. As what Thakur sir has already mentioned, that Gujarat has to be #1 in the semiconductor industry. So above the soda ash, it will be semiconductors in next 2 years. But on the same lines, Girish sir has also mentioned that semiconductor industry comes with huge environmental challenges. So looking to the importance of semiconductors, that we can't live without semiconductors. The mobile phones, the electronic gadgets, across you see, we are glued to semiconductors. So we have to talk about sustainability, we have to talk about semiconductors, and that means we have no other option but to talk about environmental management focusing semiconductors. So I have a very distinguished panel coming from, like we have Anand sir from Central Pollution Control Board, we have industry, we have scientists, we have all people put together, and this becomes a very powerful panel to talk about semiconductors. So now I would begin my discussion with Anand sir from Central Pollution Control Board. Sir, you have been instrumental in devising and categorizing the policies for semiconductors in terms of category. Could you please highlight that how categorization of the semiconductors is a semiconductor industry and what are the typical pollution loads?
Thank you, Anuragji, and good afternoon to all. And thank you, organizers, for inviting me. And I'm feeling proud that I am part of this great conference. And very good questions from you. We have been asked to categorize semiconductor industry. And this industry presence in the country is not there right now. So last year it was asked that we have to, so there is a laboratory, semiconductor laboratory in Chandigarh. They also manufacture semiconductors. So we had intensive interaction with them. We went there, we studied there. So first I would like to tell you how we are arriving at the methodology is that we go by the pollution potential. So pollution potential of the industry is measured in terms of pollution index score.
So for arriving at the score of a particular industry, we assess its water pollution potential in terms of the pollutants, water pollutants, and then the volume of water being used and consumed and the volume of water generated. Similarly, for air pollution potential, we calculate the score based on the criteria pollutants present. We have a elaborate methodology for giving a scores for different kind of industries based on the pollutants. Similarly, for air pollution, type of fuels which you are using and the technology required for managing the pollutions generating from by using those fuel is also is a criteria. Then there is a third criteria is hazardous waste generation. So these three pollution potential aspects were considered. And then there is a score. If the score is 60 and above, it is red category. And if the score is between 41 to 59, it is orange category. And if the score is 21 to 39, 21 to 40, then it is green category. And it's up to 20, it is white category. And categorization basically helps us in giving the consent period. For red category, it is 5 years, I think, and the verification is very frequent. Similarly, it goes down. For orange, it is 10 years, and the auditing frequency is little bigger number of days. So now coming to the semiconductor industry, the four type of manufacturing was envisaged. One is semiconductor fab manufacturing. Then the second was display fab manufacturing. And then the third was the compound semiconductor, silicon photonics, sensor fab manufacturing. And then the fourth one is semiconductor assembly, testing, marking, and packaging facility. So there were four kind of manufacturing envisaged for semiconductor in the country at this point of time. And there are various technology for doing this, but we are not going for technology. So when we studied, then the fab manufacturing got 85 marks. And the display fab and compound semiconductor got 80 marks. So these three categories have been combined as a red category. And here we, actually in semiconductor industry, one has to know it is a nano level manufacturing, and it needs everything pure. They use the word ultra pure. Means there is purity, but here it is ultra pure. Even water is ultra pure water. The gases are ultra pure gases. The chemicals are ultra pure chemicals, because any pollutant or anything which is not required there, if it comes, because you see, they go up to 10 nano. You can understand how small, you cannot see with your eyes. So if this kind of manufacturing is happening, then you need a very high level of purity. So these manufacturing facilities are very high advanced facilities. No pollutants or nothing are allowed. Such kind of mechanisms are there. So, so when we did, and one more thing I just want to tell you, that a facility which manufactures 30,000 of fab per month, then it generates almost 6 million liters of wastewater per day. So for that, it will be needing 9 million liters of water a day. So you can see how much the water intensive this industry is. Then secondly, the gases. There are cleaning gases, the etching gases, every type of gases are used which are having use in the manufacturing, and these gases generates the emissions. So we found that for the wastewater, we are getting high COD, we are getting very low pH, we are getting heavy metals, and we are getting organic solvents compound, because they use all kind of acids, hydrochloric acid, nitric acid, HF, HCl, sulfuric acid, all, then etchants are used, then some cleaning agents are used. All these are patented, and these are highly acidic chemicals. So in the wastewater, these are the pollutants. Similarly, for air pollution, since gases are used, so gas management is a very challenging job here. But commonly, I will tell you that chlorine gas is coming out as a pollutant, HCl is coming out, HF is coming out, oxides of nitrogen is coming out, then heavy metals also coming out in terms of lead and arsenic. So these are the pollutants which comes in the manufacturing of semiconductor industry. But semiconductor industry is the need of the hour. So we have to have pollution control measures and we have to have those industries. Thank you.
Very rightly said, sir. As what sir said, ultra pure. Everything is on ultra pure. So we require ultra pure water, and then the type of water footprint which is there, which is very high. So keeping this in mind, we would like to have some international experience. So Kinjal, what is your experience regarding Taiwan? Let me just highlight a 1,400 hectare plot of the Hingshung Park of Taiwan. That has come into a big news. 363 billion revenue in the year 2022, which is half of Taiwan's GDP. That is just coming from that is from the science park. So Kinjal, can you suggest or can you put forward how are they managing their pollution when they are the hub of the global hub of semiconductors?
Thank you, Anurag ji. After PhD, I get a chance to work with the Taiwan government, and I was the part of like GPCP board here. Like that, we have a NEP2, National Energy Program, Phase 2. So I got a chance to visit several industry for audit. So in that case, Taiwan is a semiconductor hub. So total GDP, Taiwan's total GDP, 50% is just generated from semiconductor. So that is the biggest things. And semiconductor, they need the huge amount of water. So Taiwan is also looks like a Gujarat. Okay, Gujarat also, we have the same sea area. Taiwan is surrounding by all sea. So we have the opportunity to utilize their knowledge to our sea coastal area. So Dahej is also one of the good place where we can generate semiconductor industry. So now come to the point, when we consider about semiconductor, we have to consider about the air, water and the soil pollution. So the air pollution, the highest generation of the VOC from the semiconductor industry. Okay, another is the CO2. So now when the carbon taxation start in 2017-18, okay, so these countries are already moved forward to become a zero pollutant, or maybe less amount of CO2 comes out. So in that case, it is very difficult to manage. In that case, they manage by circular economy. So circular economy means waste of my industry can be the feedstock for another industry. In that case, they use the CO2 by carbonation process to cement industry. So carbonation process, they use the calcium oxide react with CO2 to convert to calcium carbonate. So the similar way, they also converted the alkaline wastewater. So alkaline wastewater is the highest amount of water generated from the semiconductor industry. So this alkaline wastewater and CO2, they converted to in circular way to minimize their waste. Second is they also use the RTO method, because when we use the oxidation, when we use the photocatalytic oxidation, everywhere we have the waste. But where we use the RTO method, there is a ceramic chamber where they give the furnace and they heat. In that case, the generation of the heat and the reaction, the decomposition means conversion of CO2 and H2 is the highest amount. Maybe we can say 95+%. So they use this technology to minimize the CO2 conversion and the water conversion. Now, when I went to the Hsinchu, so Hsinchu means Taiwan, if we talk about semiconductor industry, so CSMC is the largest one. If you use the mobile phone and everything, we consider 30% of the total global market is covered by CSMC. Okay, so this is the biggest industry in Taiwan. And when I visit, they have 3 parks. One is a Hsinchu, Tainan and Taichung. Taichung and Tainan plant is inaugurated in 2026, and that is a zero discharge plant. So they are in the way to generate a zero number of pollutant. Okay, so this is the biggest learning from us. How this small country can generate and can fight against this pollution because of the 3C policy. Coordination, cooperation, collaboration. They are always ready to cooperate. They are always ready to change and collaboration. So this is the biggest plus point for them. So now this means these 3 parks, if you see, they are very near to the sea. Why? Because they want to be a self-resilience. Okay, so they are want to generate their own power supply from wind energy and offshore power, because if you consider 50% of the GDP from their country, so they are using around 8% to 10% of power of their own country. So this is a very huge amount. So that's why they are considering to use the green power supply, power generation. And that's why they are using this offshore part for generation of the power. And also if you visit the Sinchu, you can find the bioretention plant, because as the doctor mentioned, we have a heavy metal pollutant, arsenic and all. So this cannot be mixed with the water when the flood will come, because Taiwan every 3 or 4 days have a heavy rain. So they have generated biopark, or maybe we can say amusement parks to do bioretention. And this plant can retain the heavy metal runoff. So these all are the measures taken by the Taiwan government and with the help of the TSMC and the big industries to mitigate the
Yeah, absolutely fine. The word zero discharge, that is music to our ears. That can we have a park, zero discharge, and we have no pollutants. The 3C which you mentioned, definitely these are clues. You also mentioned on green power, and we get to know that semiconductor industry is a very energy intensive industry. So let's hear from Vinod what he has to take about how the semiconductor industry can be little more energy efficient and how they can reuse more of renewables, and what is your take from the CII background?
Thank you for your question. I think it's a very valid question now because we are setting up a large factory. The energy requirement for all the factories would be very high. So if you see the total semiconductor industry as a sector in the global, the energy consumption of the entire the semiconductor industry is roughly about 250 terawatt hour. So that is equivalent to the Australia's, the country's energy consumption. So that's a size of energy requirement we need for the semiconductor. And if you talk in terms of emission, it's emitting about 500 million ton of carbon dioxide across the globe. So this is about Japan's or Korea's carbon emission. 1/3 of India's emissions, 1/5 of India's emission. So that's a sizable number of the energy intensity the semiconductor industry is going to have. Secondly, if you put the LCA perspective in terms of emission of manufacturing the semiconductor component, around 15% of the emission comes from the supply chain, which is from the material we use for the semiconductor. And 20% of the emission comes from the carbon emission or the manufacturing process. You guess the remaining 65% comes from the end user, the product which is used by the consumer and when it is disposed. So the 65% we don't have a control. So because the consumer is having their own perspective, only one option is the semiconductor manufacturer has to produce the electronic component which should be energy efficient. So that's how the semiconductor player will have a good play in it. So the remaining 15% from the material and the 20% from the manufacturing process is under control. Yes. So now India has the ambition of becoming net zero by 2070. So this is a very ambitious target. The different countries have taken the different target. So this 20 plus 15, 35% of emission can be controlled by several methods. One, we can have an energy efficiency in the manufacturing process. Second, as the eminent, the people on the dais also told, using the green power. So we should have a maximum utilization of the green power, which is renewable power. Gujarat as a state, which is a leader in generating the green power. I think roughly about 10 to 15% of the total country's renewable generation from Gujarat. So which is about 20 gigawatt of the capacity. So that is a sizable number. But how to adjust this green power? So that is one question we need to have a framework on this. So there are 17 states in the country which have introduced green power purchase. So which means you can buy the power at premium rate so that you can buy the green power. That is number one. Second, we can have the green power market development group. So this is to have a buyer and the developer, the semiconductor fab factory and developer of the solar panels, solar developer should join together and contribute in terms of using the green power for their own factory. So we have a very good experience in having this green power market development group from CII. So way back in 2017-18, we have facilitated 7 states, and we have facilitated this green power marketing development group. We have facilitated about 650 megawatt of green power purchased for the 450 consumers. So that is one of the good approach we can follow for the semiconductor when the large amount of factory is going to be in place in Gujarat or any other state per se. So we should have this GPMDG as one of the component or one of the framework which should be working effectively to reduce the emission from the factory. So by doing this, definitely we can able to achieve the India's ambition of reducing the carbon emission by becoming net zero by 2070. Yeah.
So you rightly pointed out the green power market, which has to be developed, and that will increase the sustainability of the semiconductor industry. So we heard from our panelists about the water intensity, the pollution load, the energy, and now let's come to the next part of this, and that is the processes which are involved. Green chemistry plays a very important role because we are using a lot of solvents. So how green chemistry can play a role for increasing the sustainability in the semiconductor industry. So let's hear from Aman Desai. They are one of the pioneers of our country to talk about green chemistry. Aman.
Thank you, Anuragji, for the kind question and the kind comments, and absolute pleasure and privilege to be here. Thank you, GPCB, for the kind invitation, and it's very nice to be part of this amazing conference. So I'll address the question in terms of sustainability and green chemistry as a whole in the semiconductor industry. The environmental impact of the semiconductor industry is tremendous. The use of electronics is only exponentially increasing in the world today and will exponentially increase further. As per the Moore's law, the number of transistors in integrated circuit chip is going to double every 2 years. So as this miniaturization enhances, and as the use exponentially increases, the emissions and the complexity and the environmental load thereof is only going to become more and more complex, and thereby present significant opportunities and challenges for sustainability. You have to also look at the entire life cycle of semiconductor industry, not just the chip manufacturing, but also the supply of raw materials, as the panelists have said, the assembly and formulation, and the final disposal, and the final end life of the semiconductor as well. So the 4 Rs, reduce, replace, recover, and recycle. Talk about circular economy, talk about upcycling, talk about inherently safe processes, inherently sustainable processes. Now the chip manufacturing is the documented most contribution, has the most contribution in the environmental impact of the entire life cycle of a semiconductor industry. And that starts from the cleaning operations to the thin film deposition, to the lithography, to the dry or wet etching, to the planarization. Hundreds of steps are involved in this process of chip manufacturing. Copious amounts of solvents, copious amounts of rare earth metals, toxic gases are involved. And this represents significant challenges and opportunities for sustainability and green chemistry. And so you can talk about supercritical fluids, supercritical carbon dioxide in the cleaning operations, in the surface preparation steps. You have NMP as a solvent being used, DMSO as a solvent being used, which are tremendous, have significant flammability properties as well as toxicity associated with them. You can try to go, in fact, we as a company are developing now amide-based solvents to replace NMP as a solvent. In the chemical vapor deposition step, preliminarily today there is silane being used, dichlorosilanes being used, trichlorosilanes being used. The sustainable chemistry should point towards the use of more sustainable triethyl orthosilicate type of silanes or germanium for the deposition steps. etching is a big problem in sustainability. You use basically halogen chemistries, and so you either have fluorine, hydrofluorocarbons, or perfluorocarbons being used, or HC, or chlorine, or chlorosilanes being used. There's really no solution yet for replacing this halogen chemistry. Bromine chemistry can be used, but then the byproducts thereof have their own problems. And so this is ripe for sustainable solutions towards the etching steps. Then you come to the topic of recover and recycle. You have exhaust gases that are being produced. Can you have membranes that capture these exhaust gases, separate them and recover them? You have the rare earth metals being used. Can you now think of having some adsorptions and molecular organic frameworks, ligands, membranes to recover the rare earth metals and the precious metals and recycle them? Coming to the semiconductor manufacturing fab houses, the emissions and the energy requirements are tremendous. And these are because of the hundreds of equipments being used in the process of the semiconductor manufacture. Now, can you start thinking about sustainable methods of improving the processes to make the semiconductors? And so you go to excess heat recovery, energy recycle, optimization of the process, and then you have the electrical requirement, which is intensive for a semiconductor manufacturing. And now you can start thinking about the solar and the wind and photovoltaics and green hydrogen, biogas and such. And then I think we should not forget the end of life as well of the semiconductors, where especially for consumer electronics these days, the life cycle is only 2 or 3 years, and it all goes to a landfill or electronic waste. And I think, unfortunately, only a very small percentage of the electronic waste today is being recycled. And so I think overall this has tremendous challenges, tremendous complexities, and this is only going to increase further. But I think that also represents tremendous opportunities for us as scientists, as industrialists, as academics, to come up with sustainable solutions and sustainable improvements and green chemistry for these problems. Thank you.
Big problems comes with big opportunities for us to explore. You pointed out 4 Rs, which are very much important. How nice it would be if I recover so many heavy metals and profitably use. But typically the water intensity of the semiconductor industry is very high. The type of pollution load is also very high. So Narendra Jain sir, what is your opinion? How do you perceive the semiconductors and the water intensity usage, and how do we reduce, make it more water efficient, and especially also on the effluent management? So I would like to put this question to you, and with your experience and the vast experience which you have, more than 30 years. So please comment on this.
Thank you. It's very rarely understood by industry friends that a kiloliter of effluent discharged is not just the cost of effluent being discharged, but it's the cost that it has gone through as a fresh raw water when it came in, and thereafter the number of cycles of heating and cooling and pumping it has gone through, and the amount of chemicals which is your raw material has gone into that water to become an effluent. So if you look at that cost, it's far, far more. A 50 rupees scale water could be costing about 2,500 rupees when it becomes an effluent. So till date, I have never in my career heard of any industry closing down because of non-viability of business for becoming a ZLD. So that itself shows, because when you talk about ZLD, the focus automatically goes on reduction at source, which means they are going to save on that cost of that water becoming an effluent at such high cost. While Aman spoke about 4 Rs, I talk about 5 R and the 6th R. The 6th R, while reduce, reuse, recycle, reprocess, and reject is very well-known subject people talk about, I talk about resource substitute. Let us understand that is the 6th R and is going to play a major role going forward, because irrespective of what value addition or dollars per KL of water industry generates, what amount of money we pay to the government for sourcing that water, this scarce resource, by constitution, the priority is for domestic consumption first, thereafter agriculture, and then comes industry. So if you have money to pay, it doesn't mean that the government will give water to industry first. So that being the case, resource substitute is a major role to play. And I believe GPCB and more than that, GIDC has a bigger role to play in that. While they are building infrastructure for an industrial cluster, it should be mandated on GIDC that they should have infrastructure to bring raw or treated sewage from the surrounding areas as one source of water towards that GIDC plots. By doing that, you are going to hit two birds with one stone. You are going to take care of the sewage being discharged into land in the community, while at the same time you are producing water for industry, which is a waste from that end. So this kind of technology, that's why I said resource substitute is going to play a major role. Third important thing is the way governments pay PLIs and other incentives and tax rebates. It's high time that governments promote adiabatic cooling towers in place of water-based cooling towers. Till the recent times when the energy costs were 7 rupees, 8 rupees, 9 rupees per kilowatt hour, and today the renewable energy is coming at 2.5 and 3 rupees, adiabatic cooling towers are definitely more viable than it was 5 years ago and 10 years ago. And if it is incentivized, don't pay it in money, but allow for early depreciation. Even that is good, so don't pay out from your pocket at least. So, but that is one way of water conservation for future growth. Also, with the climate change, the way it is happening and the intensities of rainfall, what we are seeing today, GPCB will have to come out with a philosophy where any environment clearance or consent to establish granted, it should have a condition that the industry shall harvest rainwater runoff up to at least 40 millimeters of rainfall per day, or 7 days of water consumption of that industry. So that would allow a lots of rainwater from industrial sector which is running away and most likely carrying its pollutants, depending on the kind of industry, is going into the natural streams and polluting the natural streams. Instead, only the first stream, my experience, I got vast experience on this rainwater runoff collection from industrial complexes. It's only the first rain runoff which you probably have some contamination. Thereafter, the rainfalls are as good as or close to what you get from the water supply board. So this has to be inbuilt into the project construction. Thereafter, you will not get place, you will not get money. But at the time of construction, if it is given, then a good topographic study and a location would be very well settled. Now, extending this, what more needs to be done is, while the GIDCs provide you water supply for fresh water and take away the lines for treated effluents, what is missing as a policy and as an infrastructure is promoting exchange of used water among the industries within the industrial cluster. I may be generating as an industry 4 different qualities of wastewater, but today what is the infrastructure I have in the industry? Mix all and treat and discharge. Instead, if I were to have separation of qualities of water into say maybe 3 or 4 category, and if there is infrastructure within the GIDC for transporting that line to the other industries, then probably there will be multiple end users for 2 qualities of that water, only 3rd and 4th needs to be discharged. This infrastructure, if it is built at the time of construction of the project, because when the entrepreneur comes for acquiring land from you, if this is inbuilt as part of that cost, it is still sponsored, financed. But subsequently you put it as a condition in your consent to operate, then the industry goes for a 6. So PDCA, plan, do, check and act. Planning stage is very, very important, and this should keep on refining by checking what wrong we did in the past. But we are not doing that. We are continuing to do only D and A. We are neither doing P, neither doing C. So that's why we are into a vicious cycle. This is very, very important for the GIDC, and definitely as a equal stakeholder, GPCB has a bigger role to play in that. Within the industry, definitely there should be separate lines for drinking water, separate line for utility, and third line should be for used water. While building infrastructure, industries do not do that. We have one single line. That's why you can see what goes to cooling tower also goes to canteen, also goes for gardening, also goes for reactor cleaning, also goes for floor washing, also goes for vehicle washing and equipment washing. because one header is there. So industries also should look at how we can have 3 lines, so thereby enhance utilization of used water. So this is very, very important also from the point of water sustainability. So now, while we are talking about these things, on effluent management, he spoke about pinch technology is well established in identifying connection between one source of effluent going to the second source as raw water and replace fresh water. This more and more expertise will have to be developed within the industry, within the consultancy groups, within the pollution control boards to promote this concept of exchange or reuse of water. Maybe a couple of points more before I close. While I was reading through the data what Mr. Thakur Saab presented, Gujarat, number of industries, the right side table which you saw, 43,000 small scale industries and very minuscule numbers of large and middle, which means the group which has low knowledge, low finance is much bigger than the group which has got enough resources and knowledge. That being the case, in my view, as a guideline, GPCB in the last 3 years I have seen has gone from random regulation to guidelines-based regulation. And that's a very good move in terms of bringing uniformity or upgrading that category of small-scale operators to comparable with the large ones. So one good guideline incorporating the best practices in water conservation and effluent management should be a guideline which should come across, because that group of small industries will look at guidelines, they understand and they implement, they will find resources and they'll implement. So this is one area where there is a role which can be played by the water experts and promoting in bringing out a guideline on water conservation and effluent management. This can go on, but I have finished my 3 minutes.
Very nice, sir. I really appreciate that you said that how nice we will have multiple pipes so that you can have the different type of waters to be used, and that is how you will promote the recycling and the reusage of the water. So very rightly pointed out, and you added the sixth R, the resource substitution. So that is also very important, and that can only be happening once we are having a proper infrastructure in place. So sir, you talked about the water water framework. Going down to another level, I have Apurva to talk about what are the specific things which need to be taken up for the wastewater treatment focusing the semiconductor industry. Yes.
Hello. So thank you GPCB for giving this opportunity. So I am not expert on the environment, but I can share my experience based on my greenfield experience. So in the design stage, we generally see all these electrical line, HVAC line, but the environment part is always missing when we design when we are thinking on the design or putting the project. So my request to all this panel and all this project initiator, that we have to think about environment aspect at the design level, because once you complete the project, then retrofit is very difficult. As a user, I can say it's very difficult as a retrofit to do all these changes in the water treatment system. So my suggestion is, because now industries are generally designed at the 70% recovery. So when we discuss with any consultant or any designer or any contractor, they say we can recover the water at least up to 70%. But 90% recovery can be possible. For that, we need to add the tertiary, right? Primary, secondary, tertiary, then RO, ultrafiltration. So that can be possible up to 90%. But for that, we need to take effort at the design level. And once, yes, this is costlier affair, because it's very treatment cost is very high. But at the design level, if you are thinking like zero liquid discharge in the Sanand, right? So what generally industry do? They generally recover up to 70%, and 30% they will use as a evaporate that water, whatever the balanced water, they generally evaporate through evaporator, right? Or you can say vaporizer. But finally, that is also energy consuming approach, right? Going with the zero liquid discharge, with the evaporizer, you need to go with the energy, power, or otherwise gas. So again, that's not, you can say, green way to treat the water. So what I understood from my experience of, we can reduce up to, recover up to 90%. For that, our target should be MLD, minimum liquid discharge. So if you want to save millions of MLD water, then use MLD approach, right? Minimum liquid discharge approach, and then 10% or 5% we have to evaporate that water. Or otherwise we can use that water if some industries has this type of, they have requirement of this type of water, we can give that water to that industries. But at design level we need to do, as a project head and as a greenfield project experience, I always try to accommodate whatever the safety related, environment related concept, new concept. Incorporation at the design level is very important. And this is the time in the Gujarat where our industries are in the design stage. So this is the perfect time to incorporate all this new scheme or recovery percentage up to 90% or 80%, whatever we want to think, that we can able to achieve in this phase only. Otherwise, it will be very difficult. And for that, we need a support from industries, we need a support from government, and we need to make some state level, you can say, committee to give this information to all the industries.
So two of our panelists, they have strongly focused on that, how important it is planning. For example, Narendra sir has said, in PDCA, हम PD करते ही नहीं हैं. हम सिर्फ EC करते हैं. So that is very important. And Apurva ji is also pointing out that how important it is to have it in the planning stage. And once we are doing it in the planning stage, definitely we can talk about sustainability in a very cost-effective manner. So that is one part of the entire semiconductor industry. Now, when we say the semiconductor industry is operational, we have a lot of electronic products coming up. And once the electronic products are there, after their shelf life, we have a huge electronic waste. So now, very important thing this panel needs to answer, that what are we doing in terms of electronic waste? A small number that we have been generating around 42 million tons per year of the electronic waste. So does extended producer responsibility concept be a part of this electronic industry? So I would like to ask Anand sir, who's from Central Pollution Control Board and heading the electronic waste division, how he perceives. Sir, what is your take on the EPR for the semiconductor industry or in general?
Thank you, Anuragji. For management of electronic waste, we have rules, and you specifically asked for semiconductor, but all these semiconductors are going into all the equipments, because without these semiconductors based ICs and diode and whatever components, no equipment can function. So for management of electronic waste, we have e-waste management rule 2022. Previously, it was e-waste management rule 2016, which was superseded by 2022 rules. So the extended producer responsibility concept was introduced in 2016. So first we should know what is extended producer responsibility. A producer is a person or the company who sells electronic equipment. A brand owner, like Apple is a brand owner, so Apple is a producer. Similarly, Samsung, Panasonic, these are the companies you might be knowing who are selling equipments. And in all their equipments, these semiconductors are being used for running these equipments. So we have a list of 106 equipments under 7 categories: IT, consumer, heavy tools, lighter tools, medical equipments, laboratory equipments, toys. All these categories have now electronic equipment. So 7 categories have been identified, and in these 7 categories, 106 equipments are there. Then they have been further expanded to 134. So overall 106 equipment, because one equipment will have, say nowadays, you have this for hearing, you put this earbud in your ear. So but that is not any equipment, it is multiple. It goes for mobile, it goes for laptop. So for those category of equipment also we have given a list. So now, so these producers are selling these equipments. So as long as you are using it, it's perfectly fine. But when you discard or when you give it to the second user, and after the second user, when it become, it cannot be used further, even after repair, what happens? So for managing those aspects, the producers of these equipments were asked, you have to manage these equipment post-consumer stage. So this obligation to producer to the post-consumer stage management of the electrical and electronic equipment is called as a extended producer responsibility concepts. So for managing this, previously we used to have the manual authorization system. Now government has introduced the portal-based system. Portal-based system means faceless and transparent system. The applicant, all the producers has to register on the portal. Nowhere in the world this system is working. Only in India we have introduced since 2023. So all the producers of electrical electronic equipment has to register themselves on the portal. And there they have to give their sales figure, how much they have sold in the market. And we have a formula in the system. So each of these equipments have been given average life based on the we had a intensive consultation with producers, experts, and then the secondary research, then what is happening in the other part of the world. So based on that, all these 106 equipments have been given average life. For example, your smartphone has a 5 years life, and your feature phone has 7 years life in the system. Okay, and so based on that average life, we calculate generation of e-waste for that particular item code. For example, I will give this smartphone has got item code of ITW15. So that life, so say we are sitting in 24-25. So any smartphone which was sold in 1920 is likely to be e-waste in 24-25. But see, I have said average life, and we have given a target of 60% for this period. So we are assuming that 40% of the equipment will remain with the user, 60% will only come as a waste. So this 60% obligation producer has to meet. So now in this new system of portal based, we have said you have your obligations are visible on the portal. So his 60% equipment obligation in terms of metric ton is visible on the portal. Then we have also asked that the recyclers of the e-waste has to register on the portal. So, and recyclers will recycle this equipment, and then the end product he will sell. And sales proceed or sales of invoices, which is GST linked, will come on the portal, and based on that the certificate will be generated. So this EPR certificate is visible on the portal, and the producers have to buy corresponding amount of certificate on the portal itself. So this is the regime which is there.
That's really very interesting, sir.
And this is nowhere in the world it is being practiced. In India, it is being practiced for electronic waste, plastic waste, tire waste, battery waste, and now used oil also has been included. 2 more waste will come under this category, that is end of life vehicle, and then the construction and demolition waste. So 7 type of waste will be covered in the EPR regime. So now coming back to semiconductor, so e-waste, I told you this, all the producers have to register on the portal, and they are registering. Almost right now, we have now almost all the brands which you can name, it is on the portal. Now there is another category of the producer, which is importer, who imports electronics, irrespective of the brand. So those importer also has to register. The custom will not allow their import unless and until they are registered on the portal. And we have direct connectivity with the custom. So any person who wish to import electronic equipment, he has to have registration, otherwise he will not, and then he has to pay damages. This is happening. So this forum I will again use. If you are not registered and you wish to import, please register on the portal. So, okay. Now coming back to this, and the recyclers have a greater responsibility because they are recycling. So we are also have a auditing modules. We have just developed, about to launch. And before that, we are doing physical auditing. So we have engaged institutes of higher education like IITs, like NITs, government engineering colleges, other institutes, and we have asked expression of interest from them, and then we have selected auditors, we have given them trainings. So these auditors, because we have to do third-party auditing, and we have to do ourselves random auditing. So these auditors will be going. So from the 4th week of July now we are going to start this auditing system. So each and every of the recyclers will be audited in terms of their capacity, how much they have recycled, and the invoices which they have uploaded based on GST, whether that is correct or not. So all these things will be audited. So this is the extended producer responsibility concept for presently for the e-waste management. So thank you very much.
That's a very, very comprehensive answer. It's like starting from the left-hand side of the equation to the right-hand side of the equation. Sir has included everybody so there is no, I don't think so there is any loophole in that. And I think extended producer responsibility will play a very pivotal role in talking about the sustainable development. So since we are running short of time, I will have a last question. Looking to, sir, the guidelines which we have worked out in India, Kinjal, how do the international market, especially Taiwan, because they are hubs of the semiconductors. So a last question to this panel. We have more questions, but looking to the time constraint, we are curtailing the session. So the last question from you, Kinjal, that how does electronic waste being managed outside?
Okay, so I will give you very quick answer.
Very brief and very quick answer,
very quick
yes.
answer. So in international market, they have all calculation, how much they have used. So if you use the smartphone, iPhone 6, so they know how much copper, how much gold, how much platinum has been used in that. So based on that calculation, whoever is doing the e-waste recycling, they can extract it. So based on their calculation, they can easily calculate. I have extracted 80%, 90%. So I work with the UVIN nanotechnology company as a consultant. So they have designed chemical 10-liter solution. They can extract 90 grams of gold from that. So for that, they have to use the 10,000 pieces of iPhone 6. So this is the market in China, in Japan, and Taiwan they are working on. But the thing is the honesty based on that in between. So this is like, no one want to change that circuit board, okay? Otherwise what happen, sometimes some developed country or somewhere, they remove their metal part. Only the epoxy resin circuit board only comes on your hand. And then you cannot get the yield according to that. So this is the policy maker has to make a policy to control that, and we can get the highest number of yield to meet that requirement.
Yeah, very rightly pointed out. So now we will have a last question and the concluding remark from Anand sir from CPCB. Sir, how do you perceive the circularity or, yes sir, your take.
I just wanted to add one more thing. See, I have said 106 equipments have been identified. So we have also identified the average percentage composition in terms of 4 metals, like gold, copper, aluminum, and iron. There are other metals also, rare earths are there, but presently since the recycling capability is not so high, so only 4 metals have been identified. For all these 106 equipment category and equipment type, we have given the percentage metal composition. And this composition is also the recovery potential also included in that. So see, if I am say, and then there are 13 equipments where gold is there. So we have given those. So a recycler cannot generate more weight of percentage composition. He cannot exceed that. That is the one limit we have given. And then the end product which he is selling, so this also we know. So coming to the circularity point, since he has to sell end products, so right now we are not putting any limit to the producer that he has to use certain percentage of recycled, because the producer will use end products only when the quality of the end products will meet his production requirement. So we also have to increase the recycling quality, efficiency, as well as the quality of the recycling product. But we are moving towards circularity, because once we have very good recyclers where the recycling metal is almost 99.99999 purity, then he can use it. So then we will have full circularity. That's all. Thank you.
Thank you so much, Let's give a huge round of applause for this lovely panel. Very insightful, very interesting answers to very important questions which we were posing. So, and now I hand over the mic to our master of the ceremony. Thank you so much.
Thank you so much. That was a wonderful panel discussion. Since we are running short of time, if anybody has any questions, these gentlemen are available throughout the evening, right? So you guys can directly go to them and have a conversation, ask questions, and share your concerns and get answers out of them, right? Thank you so much. But please stay back on the stage. We have to felicitate all of you for the graceful, presence that you have got here on this stage. But first, I would like to call Shri R.V. Patel, Senior Environment Engineer, GPCB, to felicitate our speaker, Dr. Girish R. Pufalli, on stage. So I would request Dr. Girish R. Pufalli also to please come on stage. And let's give all of them a big, big, big round of applause. Next, I would request Shri M.R. Makwana, Senior Environment Engineer, GPCB, to felicitate Shri Anand Kumar. I would request Shri Rahul Kanojia, Environment Engineer, GPCB, to felicitate Shri Apurva Amin. Shri Arun Patel, Environment Engineer, GPCB, to felicitate Dr. Aman Desai. Shri Dimpali Tang, Senior Environment Engineer, GPCB, to come on the stage and felicitate Dr. Kinjal J. Shah. Shri Mehul Patel, Deputy Environment Engineer, GPCB, to felicitate Shri Vinod Balakumar. Mr. Irfan Kazi, Environment Engineer, GPCB, to felicitate Shri Narendra Kumar Jain. And Srimati Shivani Bhargava, Environment Engineer, GPCB, to come on stage and felicitate our moderator, Dr. Anurag Kandya. Also, I would request the speakers of this panel, of this session, to come on stage, also with the session coordinator to take a group picture. And meanwhile, I'm going to introduce to the next session to you all. And I would request all the speakers and panelists of the next session, that is 4B, to please come forward and take your seats. Thank you so much. Thank you very much to all the panelists, the moderator, and the speakers of the previous session. Thank you very much. Now, moving forward to the next session, it is about the capacity building and human resource management. Human resource management and capacity